How many terms we see in the numerator? Anyone?
2.
Excellent. Thank you. I see 2 terms. Excellent. Okay. The fact that this one is arranged correctly with the number in front and the factors are fine, and this one is not, prompts me to rearrange. I will rearrange and I will write 6, x minus 1 to the third, x plus 2 to the third, minus 3, x minus 1 squared, x plus 2 to the fourth. As one of my friends likes to say, I run a clean ship. Okay, so I run a clean ship. That's what he says. I don't know exactly what he means by that, but I know what I mean by that. So always keep in mind 2 keywords in math. They are factor, a very important keyword. You should always have it in the back of your mind. And the other keyword is simplify. Simplify, factor, and simplify. Sometimes they mean the same thing, depending on the problem. But here, I'm going to ask you what are the common factors in the numerator. And you will say,
x minus 1 and x plus 2.
You will say 3. Definitely you will say, very good, x minus 1. We'll talk about the power in a minute. And you will say x plus 2. Very good. And then we will open brackets. At this point, we have to decide about the powers. X minus 1, what power I can pull out?
Would it be 2?
I'm sorry? I just couldn't hear you.
Would it be 2?
Absolutely. The smallest of the 2. Well done. What about power for x plus 2?
3.
You gotta pull out.
Say it again.
Why is it 2 and 3?
You have 3 matches. I have 2 matches. How many do we have in common?
2.
2. You have 3 pencils. I have 4 pencils. How many do we have in common?
3.
That's it. Better?
So it's just the lowest of the numbers.
That's it.
Inside of the
It could be a negative number. It could be a positive number, but it has to be the smallest of the 2. Very good.
Okay,
So, thank you. From 6, I took a 3 out. What is left in front of this? 2. Very good. From power 3, I removed 2 of those. How many I still have left in the problem?
X minus, or just 1.
Very good, 1 of them. From 3, I removed 3. There are none left. I reached the negative symbol. Here it is. From 3, I took 3 out. There is 1 left, but we don't have to write it. I had x minus 2 squared, and I took them all out. And now I have x plus 2 to the 4th power, and I took 3 of those out. And in parentheses, what will I have left?
X plus 2.
Indeed. Thank you very much. Great job. Only now, never before, I can do this. Because we can only simplify factors. We simplify factors, comma, never, terms. So once I got it in the factored form, I was able to simplify. Of course, I have to distribute here and finalize the answer. So I have a 3 outside and x plus 2 cubed. And in parentheses, now I can change the parenthesis into a bracket. There is no need for brackets anymore. I'm going to remove it. I can downgrade it to a parenthesis. And we have 2x minus 2 minus x minus 2. Of course, this is multiplied over x minus 2 squared. And finally, we have 3 x plus 2 cubed, and x minus 4 over x minus 1 squared. Extremely important type of simplification by factoring that is extremely useful for chapters, especially 4. And that was problem 13 from the skills assessment, in my case anyway. So now we have a question on problem 14. And after that, I would like to also look at problem 16 to show you the method I recommend. Of course, I think I mentioned that. I'll mention it again. Any method is acceptable, just not the guessing method, or I've done this with a calculator or something like that. You do not have to use my method. I highly recommend it, but something else may be easier for you. And I will always agree with it. So we have a function p of x equals negative x cubed minus 9x squared. And we're asked to find the y-intercept and describe the end behavior and determine the zeros and their multiplicities. We're not asked to graph. Okay, so in order to find the y-intercept, what do I have to find? Or how do I calculate or determine the y-intercept? Say it again.
Where x equals 0?
When x equals 0 will be the y-intercept indeed. Oh, this is not a good one. So p of 0 will be 0. So 0 comma 0 is the y-intercept. We are asked to find the end behavior, but I would like at this point to also find the, because I think it's beneficial to answer part A and then part C and then part B. So, because these two are connected. This is not connected to these two. So let's find the zeros first. So by zeros, we mean the x-intercepts. Or where the function crosses the x-axis. And of course, how do I determine that? What do I have to set up first in order to determine them?
You would factor or simplify your equation, pull it apart. Basically.
So I have to write the equation p of x equals 0. That's my first step, right? So the y-intercept requires x equals 0. The zeros require y equals 0. So I have to set y equal to 0 or the function equal to 0 and then solve for x. Agreed? Everyone?
Yes.
Thank you. So negative x cubed minus 9x squared equals 0. So remember what I said from the very beginning of this page anyway. These two keywords, factor and simplify, should always be alive in the back of your mind. I see two terms that are negative, and especially the leading coefficient is negative. I refuse to deal with something like that. I will immediately divide or multiply, doesn't matter, same thing, by negative 1. Once I simplified everything, I simplified by removing the negative coefficients. Now, of course, I'm going to factor. Okay, so yes, I will factor out what?
X squared.
Excellent. And I get x plus 9 in parentheses. At this point, and even before, I'm going to ask you to give me the degree of this polynomial.
Degree 2.
The degree is?
Third degree polynomial?
The degree is 3, is the highest power of the variable. This has degree 3, this has degree 2. Degree 3 is the one that dictates. Degree 3 is the degree of the entire polynomial, which absolutely means 3 zeros. They may all be the same, we don't care. but it automatically means 3 zeros. Okay, I already have 1, which is -9. And how do I get 2 more zeros? Where are they coming from?
With x squared.
Set x squared equal to 0.
Very good. X squared equals 0 has 2 solutions. However, they are both the same. So the equation indeed has 3 solutions. 2 solutions are 0. 1 solution is -9. So these are the x-intercepts. The question is also asking us about multiplicities. Why are they important and what do they mean? So the multiplicity refers to how many times a 0 appears. How many times a 0 of a function appears. How many times? Well, this one has multiplicity 1. But this one has multiplicity
2.
Excellent. 1 plus 2, the number of multiplicities. 1 plus 2 has to equal the number of zeros. Always 1 plus 2 has to equal number of zeros. Okay, but what do they mean? Okay, fine.
Can we go back on that? You said 1 plus 2. Can we go back on that?
Yeah, it's the 3 zeros.
Oh, okay.
1 plus 2 has to equal the number of zeros.
Okay.
Very good. So, well, what does this mean? Yeah, I can tell that this solution appears once and the multiplicity is 1 and this 2 and the multiplicity 2. So, but what is the point of this? It's very important, actually. So let's look at few graphs. So I'm going to graph this. 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 Okay. Obviously, we have 5 different situations here. A cross, a slow cross, a very slow cross, a turn, a very slow, I shouldn't say very, a slower turn. And I can graph one that is even slower. But they must be different. The ones where the function is crossing, of course it can come from above. It doesn't have to come from left to right. It can come from above, left, and down, right. Same thing. But these are odd multiplicities. And these are even. An even number of multiplicities. So when I see that the graph crosses fast, I know that this multiplicity is 1. In other words, this 0, this x-intercept, has a multiplicity of 1. Appears only once. Of course, this one is 3, this one is 5, and so on and so forth. When it turns quickly like this, it's this situation. So this is a multiplicity 2, and this is a multiplicity 4, and so on and so forth. So that's why the multiplicities determine the zeros of a function and their multiplicities. This tells us a lot about the function. It tells us where it turns, where it crosses, and how it turns and how it crosses. If it's multiplicity 1, no discussion, it's just a straight cross. But if it's multiplicity 3 or more, it will cross only in 1 point. 1 point, but very slow. It will not rush through it. It will take its time. So if we go to the graphing calculator and we just put in, let's say, x minus 1, and if I put x cubed, you will see the difference. So I'm graphing x minus 1, I'm graphing x cubed, and I'm using the standard viewing window, and let's see what happens. As you see, the red graph takes its time. The blue graph is crossing very fast. But the red graph, it takes its time. It's not crossing at 0. Why? Because it has 3 zeros at 0. It's like this. Now if I add another graph with, let's say, in parentheses, x minus 4 squared, you will see that this graph will turn at 4. Here it is. Why it turns at 4? Because at my x minus 4 squared has 2 zeros at 4.
Why does it have 2 zeros if it touches 4 at one point?
Very good. So if I solve the equation x minus 4 squared equals 0, this is quadratic, must have 2 solutions. And the 2 solutions are x minus 4 equals 0 and x minus 4 equals 0, which means 2 solutions, x equals 4. It's quadratic. If it's quadratic, it must have 2 solutions. So it has 2 solutions because they are the same. Multiplicity is 2. The function turns at that point. Any questions? Okay, so now let's
I
discuss.
have one.
Sure.
So, what is the end all answer that we're supposed to put for B? Are we supposed to put that like it crosses? Or
We haven't
something?
discussed B yet.
Oh, okay.
So remember we talked about the y-intercept and then we talked about the x-intercept. We jumped over B for a second.
Okay.
I don't think that this is the correct order. These should be one after the other, and then this is the third one. So we haven't discussed part B yet.
So how would you like this to describe the multiplicities? Would you like us to just write 0 has a multiplicity of 2 and 9 has a multiplicity of 1?
Right. So 0 multiplicity 2, negative 9 multiplicity 1.
Just as simple as that?
Yes.
Just m equals 2, m equals
Yeah,
1?
or you just write multiplicity 1. If you want to write the entire word, that's fine.
Gotcha.
Yeah. Just explain that that represents multiplicity 1. You can write, I would love to see that, normal cross on the x-axis or the x-axis. It's a normal cross. And this is a turn. A normal turn if you want. It's not a slow turn. It's a normal turn. It's this one. And this is a normal cross, which is this one. And now when we talk about the end behavior, which is part B, we talk about where the function is going or what is the trend when the function is, when the x values approach positive or negative infinity. So let's take a look.
Which graph?
Say it again.
Which graph did you want the end behavior of?
We only have one function.
Oh, sorry, you were talking about the one on, yeah.
We only have one function, and this problem has part A, part B, and part C. We are all, these three are referring to this function. Negative x to the third minus 9x squared. Okay, the end behavior for polynomial functions. So let's review that quickly. And I'm going to put here for polynomial functions. For polynomial functions. There are only two types. Odd degree and even degree. Very simple. Odd degree, even degree. The odd degree have two options: to start at negative infinity and do whatever and go to positive infinity. I don't know how many turns, how many x-intercepts, it depends on the degree. Or, so this is from negative infinity to positive infinity. And the other one, to come from positive infinity and go to negative infinity. These are the only two options. The same thing with the even degree, only two options. Whatever, come from positive infinity and go back to positive infinity, or whatever, I don't know how many turns, from negative infinity and go back to negative infinity. When do all these happen? Here is the idea. Positive leading coefficient, negative leading coefficient. Positive leading coefficient, negative leading coefficient. So now we can identify the end behavior for our function. I'm going to copy it again here. P of x equals negative x to the third minus 9x squared. Again, I'm going to ask, although we know the answer, but if you'd like to tell me again what is the degree of this, so we know which category we are looking at. We are looking at odd or even degree. Good. So it is an odd degree, so degree you already told me is 3. So this is not relevant. So which one is it? With a positive or with a negative leading coefficient?
Negative.
Negative. Since it's a negative leading coefficient, this is the end behavior. So when we get to graph these functions later on in the semester, in the table, we will have infinity to negative infinity. This is called end behavior. Why? Because it's a polynomial function with a degree 3. Remember, I mentioned polynomial, not rational, not radical, nothing. I'm talking about only polynomial. So polynomial functions with an odd degree have this end behavior. And I don't know what else you have for me, and I would like to move on. I can extend this till Wednesday night if you still need time. So, but I would like to move on. But I would like to present number 16. Other questions for me before we look at number 16? Anyone?